Did you get it? Did you got the previous recording?
Yes.
Okay. Okay, so you can see the slides, and let me just remind you where we were last time, yesterday. And after the break, we're going to talk about the project a bit. Okay. Last time we talked about I was refreshing your memory about what you need to know so far, and we talked about hypothesis testing via test of significance approach. Can somebody remind me, when we say test of significance approach, what do we mean? Test of significance approach, what do we mean? Test of significance approach, what do we mean? Is t-statistic and p-value. Okay. T-statistic and p-value. And confidence interval approach, we construct a confidence interval. Okay. So the probability distribution of the estimators now, you know, our estimate alpha hat would follow the normal distribution with a mean alpha and the variance of alpha, and beta hat would basically do the same. Okay. Now, the test of significance approach, what we need to do in step 1, we need alpha hat, we need beta hat, we need the standard error of beta hat, we need the standard error of beta hat, and the test statistic is based on this ratio, where in the denominator we have the estimate beta hat, minus the value of beta under the null hypothesis. Now, a very specific and important case is when beta equals 0. When beta equals 0, the t-statistic is beta hat divided by the standard error of beta hat. Okay. Now, who is going to tell me, who is going to help me why beta hat is an important case? Why beta hat is an important case? Why beta equals 0 is an important case? Why beta equals 0 is an important case? Why beta equals 0 is an important case? Who is going to help me with that?
Because it means that the variable, the independent one, is not significant for the dependent variable.
Very good point. Who was talking?
Salvatore.
Salvatore, very good, Salvatore, thank you very much. So when we are testing whether beta equals 0, in fact, what we are testing is X cannot help me in explaining Y. One more time, this is important, I'm going to repeat it. What it does, it helps me to answer the question whether X can help me in explaining Y, whether X can help me in explaining why. So when I'm testing whether 0 is a value, 0 is a possible value for beta, what I'm testing in fact is whether X can help me in explaining why, whether X can help me in explaining why. Okay. Whether X can help me in explaining why. So beta equals 0. In fact, I'm asking whether X can help me in explaining why. Okay. So we're going to do this choosing the level of significance, and we have 3 levels of significance that are important. This is the 5%, the 10%, and the 1%. Now Gretel automatically gives 2 stars when something is significant at the 5%. It gives 1 star when something is significant at the 10%. It gives 3 stars when something is significant at the 1%. Okay, let me remind you here what we did yesterday in Gretel. I'm going to show you later. What we did in Gretel. So in the end of this coefficient, we have the number of stars, and we see whether a coefficient is statistically significant. I'm going to repeat it one more time because this is very important. When a coefficient can take the value of 0, then the variable that is attached to this coefficient does not help me in explaining why. It does not help me in explaining why. Okay. The variable that is attached to the coefficient does not help me in explaining why. So it is very important to see whether a coefficient can take the value of 0, because in effect I'm testing whether the variable that is attached to this coefficient is important or not. Okay, now we have a rejection and non-rejections area. So here we have 0, and usually we have this is 0, and usually this is 1.96 here, 1.96 here. Okay, so we have the level. This is the case for the normal distribution, and these are the 2 tails. Okay. Now we can do the same type of test one side if I want to see whether something is strictly positive or strictly negative on the other side. And we perform the test. If the test statistic lies in the rejection region, then you reject the null, or you do not reject the null. So you can say reject the null hypothesis, or you can say you do not reject the null hypothesis. Okay. You should be familiar with the normal distribution and the characteristic bell shape of the normal distribution. We usually scale the normal variate to have a 0 mean and unit variance. How do we do that? We subtract the mean and divide by the standard deviation. In fact, we are also using the t-distribution a lot, and there is a specific relationship between the t and the normal. The t and the normal are both symmetric and they are centered around 0, but the t-distribution has another parameter, which is the degrees of freedom. The t-distribution we employed when do we employ the t-distribution? Who is going to help me? When do we employ the t-distribution?
To test the significant difference between mean in case of a small sample.
When do we employ the t-distribution? When we have many observations, or when we have few observations?
A small sample.
When we have a small sample. That's good. So we usually, when we have a relatively small sample. What does relatively small sample means? We don't know. Okay, so what's the difference between the normal and the T? The T, you can see, has fatter tails. Okay, the T has fatter tails. Okay, the T has fatter tails. So one important difference between the T and the normal is the fact that the T has fatter tails. Okay, fatter tails means what? Could somebody help me? What does fatter tails means?
It is less precise.
It is
Less precise because the variance is more.
less precise, that the variance is more. When we say fatter tails, what do we imply?
I think a large rejection region.
Yes, but fatter tails means what? Means that
That
extreme
there are-
values
Like-
are,
more dispersed.
yes. So somebody wanted to also say something. So fatter tails, what does it mean about extreme values? Fatter tail means that extreme values are more frequent compared to the normal distribution. When we say extreme values, we mean values that are far away from the mean. So fatter tails means extreme values are more frequent than the normal. Okay, what does extreme values mean? Extreme values means that, you know, when you have, for example, -4 or -5 or +4 +5 is more likely to happen than the normal distribution thinks. It is more likely to happen than the normal distribution thinks. Okay, so the tails, when we say tails, we imply what is happening in the extremes. The tails implies what is happening in the extremes. Okay, any questions so far? Okay, is this clear? Okay, so the T and the normal, well, the normal has a specific set of critical values. The T distribution does not have a specific set of critical values. The critical values of the T distribution depend on what? The critical values
Degrees of freedom.
it depends on the degrees of freedom. So how many T distributions there are? Infinite number of T distributions. Okay. Each T distribution has different critical values. Why? Because it depends on the degrees of freedom. The degrees of freedom are what? How can we define the degrees of freedom? When we say degrees of freedom, we mean what?
The difference between total observation and the total number of restrictions.
The number of observations, let's call it n, minus the number of coefficients we estimate.